Hello dear students, welcome back. So we are done with the question number 1 to question number 14 of this Reneet 2026 paper. Let's solve some 15 more questions. So देख ले बेटा आप. So this is our question number 16. The question number 16 is like this. It's a nuclear reaction. This is the question from the modern physics. So here let me write on first that this is a question from modern physics. Okay. The question is based on Q value of the reaction. जो हम पढ़ते हैं Q value of the reaction. Q is actually equal to what? It's equal to delta M multiplied by C square. Let me first of all calculate the delta M. Now what is this delta M? This energy is here released. We'll assume that. So delta M implies that the mass of the reactants minus the mass of the products. Mass of reactants assumed to be greater than the mass of the products. The difference of the two is called as the reduced mass. Okay, is called as the mass defect. So delta M will be equal to, now what's the mass of the reactants? That is, see that, have a look. 238, this is 4, this is 234, so it is same. 234 plus 4 is equal to 238. So we have to nothing to do with that. ठीक है जी. तो what's the mass of the reactants? तो mass of reactants मैं यहाँ पे लिखूंगा ऐसे. I will write like this 0.050 minus the mass of this plus this is 0.043 plus 0.003, so it will come out to be 0.046, which will be exactly equal to 0.004. So this is delta M in atomic mass units. This is the mass defect. All right, now what's the amount of energy that is released? Q will be equal to delta M multiplied by C square, or simply I will do one thing, that is this here I'll simply do one thing, that is 0.004. I will multiply it by 931.5 MeV, that is million electron volt. So Q will be exactly equal to 4 into 931.5 this here keV, kilo electron volt. Okay, this 10 is per 6, so this 10 is per 3, 10 is per 3 multiplied with this is 4. So this value exactly comes out to be 3726 keV, which is the option number first. Okay, let's move to another question. Question number 17. Question number 17 is quite simple. It is not that complicated question, so easily we can do this question. The question है क्या? That is, in photoelectric effect, it's given to you in the photoelectric effect, if the power of the source obviously decreases linearly with the time. It decreases linearly with the time. What about the photoelectric current and the stopping potential? ठीक है जी. Okay, so first and foremost, this power is directly proportional to intensity. Okay, in fact, intensity is defined as energy per unit area per unit time, or it's defined as power per unit area. So intensity is power is directly proportional to intensity, and intensity is in turn directly proportional to current. So that implies if the power decreases linearly, this implies that the current decreases linearly. Okay, number one. Number second is that intensity and stopping potential are not connected. Stopping potential has something to do with the frequency. Stopping potential is directly proportional to the frequency of the incident radiation, provided it is greater than the threshold. So that means the stopping potential will remain constant. Stopping potential stays constant, which implies that if you will plot current versus, there are 4 different options given to you. So the current versus time graph will be like this. It will decrease linearly with the time. And what about the stopping potential and this? The stopping potential with respect to time will stay constant. So like this is the graph. Okay, let's move to another question. Question number 18. Question number 18 can be done easily. It is not that difficult question. So in the diagram, there are 3 different capacitors given to you. One is P, Q and S. There are 3 different capacitors, P, capacitor Q and capacitor S. And capacitance of each capacitor is given to you, that's equal to C. Okay, then the question is, energy stored in this capacitor is, that is UP. Okay, all right, the energy stored in this capacitor is UP, and the total energy stored in all the 3 capacitors is equal to UT. Question is, calculate the ratio UP divided by UT. That's what you are supposed to calculate. Okay, So first and foremost, let's try to calculate the total capacitance. What will be the C equivalent? That's equal to, these two capacitors are in series, so C and C in the series will be C by 2, and then it will be added with this, so it will be C by 2 plus C because they are connected in parallels. So the equivalent capacitance will be 3C divided by 2. Now what about the total energy stored? That's equal to 1 by 2 CV square. तो C की जगह मैं लिखूंगा बेटा 3C divided by 2 और V square के बदले लिखेंगे V square. So it comes out to be 3C V square divided by 2 into 2 is 4. This is the total energy stored in all three capacitors. Okay. Now what about the energy stored in the capacitor P? See that the battery has a potential of V, which means that it will be equally divided, V by 2 and V by 2. Okay. So from there I can calculate what is the energy stored in the capacitor P. That will be obviously equal to 1 by 2, capacitance is C, and the potential difference across that capacitor is V by 2 whole square. It comes out to be CV square divided by 2 square is 4 2s are 8. Okay. Now the question is calculate UP divided by UT. So UP divided by UT will be equal to, that is 1 divided by 8 whole divided by 3 by 4. CV square will cancel. So it is 1 by 8 multiplied by 4 divided by 3, which comes out to be 4 1 4 2. So it is 1 divided by 6. So this is the answer to this question, that is 1 by 6. All right, let's move to another question. Question number 19. Question number 19 has been, it's a modern physics question. Okay, calculation इसमें है a bit difficult calculation, but let's try to let me simplify this question for you. So it is given that there are two particles, one is photon and another is electron. They are moving in the free space, which implies in the vacuum, with energy is same, that is 20 electron volt is the energy of both the photon as well as electron. Calculate the ratio of the momentum of electron and photon. So let's try to do that. First and foremost, this equation gives you the momentum of electron. This is the relation between the momentum and kinetic energy. And this equation gives me the momentum of the photon. Okay, I will have to calculate the ratio, so I will write it like this: momentum of electron divided by momentum of photon will be equal to under root of 2m multiplied by E whole divided by E by C. Or I can write it like this: twice m root E divided by E is 1 by root E. तो यहाँ पे E आ जाएगा बेटा. This C will go in the numerator. Now let's put the values here. Momentum of electron divided by momentum of photon comes out to be under root of 2. Mass of electron, you know that it is 9. It is given in the question, but it is a fundamental constant. आपको याद होना चाहिए इसका value. 9 into 10 to the power minus 31. Energy is given to you 20 electron volts, so it is 21 electron volt is 1.6 into 10 to the power minus 19. All right, and the velocity of light, you know that it is 3 into 10 to the power 8. Now let's try to solve this equation here. तो एक हम यहाँ पे करेंगे बेटा. I will write it 2 into 9 into 10 to the power minus 31 whole divided by, in the denominator I will write down 2 into 16 into 10 to the power minus 19, and here it will be 3 into 10 to the power 8. Okay, this 2 and 2 is going to cancel. Root 9 root 16 is 3 divided by 4. 3 divided by 4, it is 3 divided by 4 multiplied by 10 to the power minus 19. ये बन जाएगा बेटा यहाँ पे 10 is power minus 13, 31 plus 19 under root of all this multiplied by, here it is 3, so I will multiply it here 3, so here it is 10 to the power 8. Now 3 into 3 is 9 divided by 4 into 10 raised power minus 31 plus 19 is what? Minus 31 plus 10 is first of all 21, so it is 12, so it is 10 to the power minus 6 into 10 to the power 8. So it comes out to be 900 divided by 4. 100 by 4 is 25. I can write it like this. Now 9 into 25, 8 into 25 is 200, so it becomes 225. This is its exact value. The ratio of this is 225. Okay, let's move to the another question. That's question number 20. Question number 20 is based on the fluid mechanics, and we have to apply an equation what we call as the Bernoulli's theorem and the equation of continuity. Okay, see that what is given is this: these are 2 points, this is point P and point Q. The pressure difference between the 2 points is given, that is 15 Pascal, 15 Newton per meter square. Area at point P given, area at point Q given, density of the water is given 1000. Then the question is, what is the rate of volume flow in cubic centimeter per second? So rate, first of all, you should know that rate is volume per unit time, which is in turn equal to A multiplied by V. Okay, then you can write like this: AP into VP is equal to AQ into VQ. This is called as equation of continuity. We have applied here equation of continuity. ठीक है जी? Okay, now we can easily calculate AP VP or AQ VQ, but only this area of cross section at the P and Q is given, velocity is not given. Now how can we calculate the velocity? By using Bernoulli's theorem. And what's exactly Bernoulli's theorem? Is this P plus 1 by 2 rho into V square equal to constant? The reason is that the height is same at both P and Q, which means PA plus 1/2 of rho into VA square equals to PB plus half of rho into VB square, isn't it? So I will write like this: PA minus PB, which is given to me, that's 15. Here I will write down 1 by 2 rho into VB square minus VA square. All right. Okay, PA divided by PB is given to me. Sorry, for example, these are 2 points A and B. It's one and the same thing, doesn't matter. So PA and PB is my difference is given, that's equal to 15, equals, this is here given 1000 divided by 2 into VB. See that ये VB और VA हमें पता नहीं है. Let me do one thing, that is VB के बदले में लिखूंगा, I will write down like this. This VB is equal to AA into VA divided by AB, isn't it? So let me write it down here. So it will become AA square multiplied by VA square divided by AB square minus VA square. All right. Okay, from here I will try to calculate what is the value of this VA. So this is here 30 divided by 1000. Let me write it like this, equals to, now what is the area of cross section at A and area of cross section B? That is 40 20. So 40, so it will be 40 divided by 20 whole square minus 1 multiplied by this VA square, isn't it? Now this 0 and 0 will cancel. This will become 3 divided by 100 equals to 40 by 20 is 2, 2 square is 4, 4 minus 1 is 3 into VA square, which implies that 3 and 3 will cancel, take root on both sides. VA will become 10 meter per second. I will convert it into the centimeters. Sorry, it is 1 by 10. It is 1 by 10. VA will be equal to what? It will be equal to 1 by 10 meter per second. 1 meter is 100 centimeters, so it is 10 centimeter per second. All right, and I am nearly done. That is the rate I have to calculate. Rate will be equal to area of cross section at A into velocity at A. Now what is the area of cross section at the point A? That is 40 and velocity is 10, so it will be 400 units. Okay, whatever the units are, 400 units. So this is the answer to this question. Let's move to another question. That's question number 21. Question number 21 is a bit complicated question. Okay, lengthy question. So the question is like this, that the stiffness constant sigma, Boltzmann constant, and the Venus displacement law constants are given. You will have to find what's the dimensional formula of this. Let's do one thing. First of all, let's calculate what is first of all the intensity. You know that this is the stiffness equation, I equal to sigma T raised power 4. Okay, where intensity is this, lambda is this, and E is this. So this is what we had to calculate. We had to calculate the dimensional formula of sigma into B divided by K. Now from this equation, can you tell me what will be the dimensional formula of sigma? It will be joule per meter square per second. Joule per meter square per second, and then it is T raised power 4, so it will become, in the denominator will be K raised power 4. This is sigma. Then B का जो dimensional formula आ जाएगा वो आएगा मीटर इंटू केल्विन डिवाइडेड बाई, फिर जो नीचे बोल्ट्जमैन कांस्टेंट है, बोल्ट्जमैन कांस्टेंट विल बी जूल पर केल्विन. तो केल्विन यहाँ पे लिखेंगे, जूल पर केल्विन. ओके, अब इसमें कैंसिल हो रहा है कुछ. नंबर 1 इज दैट दिस जूल एंड जूल विल कैंसिल, this meter and 1 meter will cancel, this Kelvin will cancel with this. So we are left with this. तो बचा इसमें यहाँ पे ये कि न्यूमरेटर में कुछ बचा, Kelvin cancel, so it is 1 by meter second Kelvin square, which implies the dimensional formula will be L minus 1 T minus 1 K minus 2. This is the dimensional formula, L minus 1 T minus 1 K minus 2. Okay, so this is the answer to this question. Let's move to another question. देख लें बेटा आप और एक question number 22. This is a very easy question. Okay, escape velocity, you should know that it's equal to square root of twice gm divided by capital R. Now it is given in the question that the mass is same and R2 is equal to R1 divided by 2. So I can write it is inversely proportional to root R, which implies V2 divided by V1 will be equal to square root of R1 divided by R2, which is equal to square root of. Now what is R1 divided by R2? That is 2. R1 by R2 is equal to 2. So the answer will be simply root 2. तो ये है इसका आंसर, root 2. Let's move to another question. Question number 23. Okay, this question is an unlike NEET question. Should have been asked in the JEE Mains or JEE Advanced rather. तो आया है NEET में. So this question is a bit complicated. तो यहाँ पे ध्यान रखेंगे आप. तो देख लें बेटा. तो क्वेश्चन कुल मिलाकर ये है कि ये है पॉइंट A and this is point B, and a charged particle whose charge is 1 coulomb is taken from one point another point, and the work done is given to you, that is rho r square divided by n epsilon naught. From there you will have to calculate epsilon naught. तो देख ले बेटा, let's try to calculate the work done if the charged particle is taken from this point to this point. All right, it's taken from this point to this point along any path. Okay, taken from here to here. How can we calculate that work done? That work done can be simply calculated by this. Work done equals to Q into delta V. Since Q is 1, so it is simply delta V. Delta V implies that it is the potential difference. All right. So W will be equal to potential difference. Now, what is the potential at the point A? It will be equal to KQ divided by 2R. This is the potential at A. What is the potential at B? It is equal to KQ divided by 3R. So simply I will write it like this. KQ divided by 2R is more potential minus KQ divided by 3R is lesser potential. So the work done comes out to be KQ divided by R into 1 by 2 minus 1 by 3 comes out to be 1 by 6. So it is 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught Q divided by 6 into R. All right. Okay. Now see that in the question the density is given and the answer of work done that is also given in terms of density. See the density. Okay. So I will try to convert this charge into density. Okay. So the work done that is equal to Q divided by 4 pi epsilon naught multiplied by 6R. Now see that this charge density rho hota hai beta charge per unit volume, which implies that the charge is equal to rho multiplied by V. So that means the work done will be equal to, here I will write down rho divided by 4 pi epsilon naught 6R into volume, but the volume of sphere is equal to 4 by 3 pi R cube. Now see that anything cancels or not. This and this is going to cancel. This 3 into 6 is 18. So it becomes rho. This pi and pi will cancel. It becomes rho into R square divided by 18 into epsilon naught. Is there anything else? No, not at all. So now compare it with this. It is rho R square divided by n epsilon naught. This is rho R square divided by n epsilon naught, which implies n is equal to 18. So this is the answer to this question. Let's move ahead. Another question is there, question number 24. This question is comparatively easier. So simply it is a cyclic process. For cyclic process, you should know that delta is equal to 0. When delta is equal to 0, delta Q is directly proportional, is equal W equal to area, and area is nothing, it is length into breadth. Now see that what's its length? So this is 300 minus 100 is 200 this side. 5 minus 2 is equal to 3. So it is simply 200 multiplied by 3. Answer aa jayega 600. So this is the answer to this question. It was easier question. Let's move ahead. Another question is there. Again, this question is not that difficult. It is easier question. Okay. First and foremost, it is given that this is solid sphere, and then there's a cavity which is inside this cavity there's a charged particle. So obviously when there is charged particle inside this cavity, the first point you will write down is that the electric field inside this cavity will not be equal to 0. That's the first point. And then this whole charge will be exposed on the surface, and it's mentioned in the question that the point B and C are equidistant from the center of this sphere. All right, which implies that the field at the point B should be exactly equal to field at the point C. तो इसका जो आंसर है that is A part. So easier question. Let's move to another question. Question number 26. क्वेश्चन नंबर 26 देख ले बेटा आप. तो यहाँ पे ऑप्शंस आपके पास दिए गए हैं. तो क्वेश्चन है क्या, you will have to plot the terminal velocity versus this is the equation for the terminal velocity. All right, you will have to plot the terminal velocity versus sigma divided by rho graph we have to plot. All right, now this is the equation for the terminal velocity. I can do just one thing, that is I will write like this 2 divided by 9 into gr square divided by neta, which is the coefficient of viscosity. यहाँ से एक टर्म हम कॉमन लेंगे, that will be rho into sigma divided by rho minus 1. All right, okay, now see that this equation, it is of the form y equals to m into x plus c, and this here m and this here x. So obviously it will be, first and foremost, it will be a straight line equation. It is a straight line equation. It's a straight line equation with positive slope and negative intercept. So positive slope and negative intercept, negative c. All right, that means this will be, this won't be the answer. ये इसका आंसर नहीं होगा, ये भी इसका आंसर नहीं होगा. इन दो में से एक आंसर हो सकता है. अब यहाँ पे 1 दिया गया है और यहाँ पे ऐसे 1 है. देख लें आप, when this rho by sigma is equal to 1, when this rho by sigma is equal to 1, 1 minus 1 will be 0. So terminal velocity will be 0 when rho by sigma is equal to 1. So that means this is the correct answer to this question. Okay, let's move ahead. देख लें बेटा आप. So another question here. Question is from the magnetism. This question is from magnetism. All right, now what is the question exactly? Current I naught is entering into this loop, and I naught is again leaving the loop. Now there are two similar semicircles, but it is given that the resistance is not same. Resistance of ABC is less than the resistance of ADC. It is half of. So that means the current will not be equally divided. It will be divided in such a way that the current here is 2 times, because its resistance that's less. So current will be something like 2x, and the current here will be equal to x. So can you make a guess? For example, this current is I naught. This has to be twice. So it will be something like this, 2 I naught divided by 3. And this current will be equal to I naught divided by 3. All right. So that if we'll add them, twice I naught plus I naught is 3 times I naught divided by 3, which is I naught. And the ratio is also equal to 2:1, because इसका जो resistance है ABC का, for example this ADC का resistance है R, तो इसका resistance है R divided by 2, which means यहाँ से current double होगा compared to this. Okay, all right, it's current divide rule. Now we will have to calculate the magnetic field at the point O. Magnetic field due to a semicircle होता है बेटा mu naught I divided by 4R. It's equal to this mu naught I divided by 4R. So that means the magnetic field at the point O will be equal to mu naught divided by 4R. I will write it down. All right. अब ये करंट ज़्यादा है, ये करंट कम है, and because of this the current magnetic field will be, because of this magnetic field will be outwards, and because of this magnetic field will be inwards. So the two magnetic fields will, they will subtract each other. So I will write like this, twice I naught divided by 3 minus I naught divided by 3. Okay, now B naught will be equal to mu naught divided by 4R. 2 minus 1 is 1, so it is I naught divided by 3, and hence it comes out to be finally mu naught into I naught divided by 12 multiplied by R. This is the answer to this question. Let's move to another question. Question number 28. So question number 28 is, it is a statement. It is very easy. It is Kepler's law. Kepler's law states that T square is directly proportional to R cube, which implies T is proportional to R raised to the power 3 by 2. So it is direct question. This is the answer to this question. See that question number 29 is a bit complicated and is unlike a NEET question. Okay, it's a typical JEE Mains question. तो देख लें बेटा आप, यहाँ पे ये दिया गया कि there are two axes, this here one axis, this here another axis, and there are two solid sphere, this here one solid sphere, this here smaller solid sphere. All right, now IA is the moment of inertia about axis number A, and IB is the moment of inertia about axis B. We are supposed to calculate IA minus IB. Let's first of all calculate IA moment of inertia about this axis for this solid sphere will be simply 2 by 5 mr square. Okay, plus now moment of inertia of the smaller sphere about this axis will be, we will have to use the parallel axis theorem, that is ICM plus md square. Okay, so it comes out to be twice 2 by 5 mr square plus the moment of inertia about this axis we have to calculate about this center of mass will be 2 by 5 small m into r square प्लस इसका जो मोमेंट ऑफ इनर्शिया वो आएगा m, और यहाँ से लेकर यहाँ तक जो डिस्टेंस है दैट इज कैपिटल R प्लस स्मॉल r. So here I will write down capital R plus small r whole square. All right, so this is IA. Exactly in the same way IB will be equal to 2 by 5 small m into r square small r square plus the moment of inertia of this will be equal to what it will be, ICM, that is 2 by 5 capital M moment of inertia about this axis we have to calculate. So about this axis of this sphere IB, it will be equal to 2 by 5 mr square plus 2 by 5 moment of inertia of this is 2 by 5 mr square. Now of this is ICM, that is 2 by 5 mr square capital R square and plus capital M into capital R plus small r whole square. Now the question is calculate IA minus IB. When we'll calculate IA minus IB, देख ले बेटा, this and this will cancel, this and this will cancel, so we are left with this, it is simply small m minus capital M into this is common capital R plus small r whole square. This is the answer to this question. Okay, let's move ahead. देख ले बेटा क्वेश्चन नंबर 30 जो है बेटा, it has been asked in it is an optics question. Okay, optics question, तो दो लेंस यहाँ पे बेटा L1 L2. This is a typical question, almost every single teacher shows this question, so let's try to do that. So first of all, for the lens L1, the lens formula will be UF divided by U plus F. Object distance given to you, that is 30, so it is minus 30. Focal length is plus 10 divided by minus 30 plus 10, it is equal to minus 300 divided by minus 20, it comes out to be plus 15 centimeters. So that means this is the object. तो पहली जो इमेज बनेगी, दिस डिस्टेंस 3 सेंटीमीटर, इट विल बी फॉर्मड समवेयर हियर, तो यहाँ पे इमेज बनेगी. फॉर एग्जांपल दिस इज I1. Okay, now this is 3 centimeter. So what about this distance? This distance will be obviously equal to 12 centimeters, such that 12 plus 3 is equal to this 15. All right, now for the lens L2, we will be again equal to UF divided by U plus F. All right, so ये जो image है बेटा, it will be a virtual object for the lens L2. So the image distance here I will take not minus 12 but plus 12, so it is plus 12 multiplied with focal length of this concave lens is minus 10 divided by 12 minus 10, it is equal to minus 120 divided by what, 2, so it is equal to minus 60 centimeters. So that means final image जो बनेगी I2, the final image I2 is formed at 60 centimeters to the left of L2, to the left of second lens, and this is its answer. This is the answer to this question. Okay, all right, ठीक है जी. Let's move to another question. देख ले बेटा question number 31. It is quite easy, without using pen paper you can even do this. This potential difference is 5 volt, this given 3 volt, so the potential difference across this 3 volt, across this will be 2 volt. 2 volt is the answer. Okay, this one is also not that difficult. देख ले बेटा आप ये question क्या है. Area of a loop varies with the time as this. So there's a loop which is placed inside the magnetic field, and the area it is given, it varies with the time, hence the EMF will be induced, and we will have to see what is power versus time graph. देख ले बेटा, इसमें दिया गया A is equal to A naught into 1 minus sin t, which means that the flux linked with the loop will be equal to B multiplied by A, so that is B A naught into 1 minus sin t. All right, then induced EMF होता है बेटा माइनस डी फाई डिवाइड बाई डी टी, दिस इज Faraday's law of electromagnetic induction, minus B A naught into differentiation of 1 is 0 minus differentiation of sine is cos, so it will be cos t. All right, so it becomes equal to B A naught into cos t is the induced EMF. Power delivered, you know that the power dissipation will be equal to E square divided by R, so it will be equal to B square A naught square divided by R into cos square t. Now we are interested in this cos square theta. कॉस ग्राफ जो होता है बेटा वो कुछ ऐसे होता है, कॉस का ग्राफ दैट इज समथिंग लाइक दिस, और कॉस स्क्वायर का ग्राफ ऐसे होता है बेटा, इट इज लाइक इट इज ऑलवेज पॉजिटिव, ऑलवेज पॉजिटिव। अब आप देख लो ऐसा कोई ग्राफ है यहाँ पे, हाँ जी है, दैट्स ऑप्शन नंबर ए, सो ऑप्शन नंबर ए इज द करेक्ट आंसर। ओके, सो दिस इज करेक्ट आंसर, दैट इज कॉस स्क्वायर। Question number 33, is this a difficult question? Not at all, it's a very easy question. Collision is given, it's perfectly elastic collision, this ball and this ball have same mass, they will collide. Whenever the two particles have same mass and the collision is perfectly elastic, याद रख लो बेटा velocities get exchanged, velocities get exchanged. So when the velocities get exchanged, that means after collision इसकी जो velocity होगी that will be equal to 10 meter per second, और इसकी velocity of this particle will come out to be 0. Now we have to calculate up to what height will this climb, up to what height will this climb, this particle. Okay, it will climb up to, for example, some height h, and we are supposed to calculate that. This v and h are always connected by this equation under root of 2gh, which implies h is equal to v square divided by 2g, which we derive from the energy conservation. Now what is the velocity? That is 10 square is 100 divided by 2 into 10, 10 10 cancel, it comes out to be 5 meters. 5 meters is the answer to this question. Okay, so this was question number 33. Now let's stop here. There are 12 more questions pending in this, we'll be solving them in the next video.